Welcome to our Enigma machine. So, to start this program, I need to click the start button. So, this is our Enigma machine program. So, as you can see, the only button that is available here to click is the load button. So, we have a tooltip as a guide to the user on how the button will function or work. So, it says here that the user need to load a CSV file from your computer library. So the CSV file, I will show the content of our CSV file that we are using in the Enigma machine. So the CSV file is the input of the program. It contains of characters from ASCII character from 32 to 125. And it consists of 90 index and 5 columns of ASCII characters. So in order to use the CSV file, we need to click the load button. We need to choose the CSV file, click open, and there is a message box. Ring file has been read successfully. So we click OK. So we have here a reset button. When the user was unable to select the correct CSV file, the user has option to load again the file. So if I click this and load again, it will successfully load the CSV file. So another thing is we can see the count of our rings inside the CSV file. We have the 5 rings in the CSV file. We also see the location of our CSV file, and we have here the ring selection and the ring settings. So first, the ring selection. So the user will be able to choose which ring in the CSV file will be used. So there are 5 rings in the CSV file, and the user is only allowed to choose 3 rings. So 0 is equivalent to 1, 1 is equivalent to 2, and so on. So I will select the ring 0, which is the first ring, the ring 1, which is the second ring, the ring the 2, which is the third ring. So if I try to make a duplicate ring selection, it will disable the ring setting. So in order to avoid it, we need to avoid duplication of ring selection. So we now proceed to ring setting or the ring rotors of our Enigma machine. So this is the initial offset of the machine that will be open when there is no duplicate rings in the ring selection. So in order to set the initial offset of the machine, the user can choose her desired setup of offset or ring rotors from 0 to 90. So the ring rotors has 0 to 90 selection. So if I try to set up, it will it will let you click the set button. So if I try to click the set button, it will allow the user to lock the setting or the selection of the rings and the ring rotors. So if I click yes, it will automatically enable to encrypt messages or type messages here in our input.
So to continue on how our Enigma project encrypted the message, I'll show you first the process of encrypting message in our Enigma. So upon the process, we use the ASCII characters from 32 to 125. So for those who don't know yet how to get the ASCII characters of these values, so just type equals and then car and then just click this value and then enter. So as you've noticed, you didn't see anything in this uh, part because the AC32 represents to space. So to get the AC, AC characters of these values, just copy the formula. So just drag it down until to the last, and then we have now these ASCII characters. So let's go back in our Enigma. So as you've noticed, we have after selecting the CSV file, our Enigma read the we have the ring count 5, but in our CSV, we you will only see that we have the router until 4, but in our Enigma we have a ring count 5. So we use the indexing from 0 to 4. So we have rotor 0, 1, 2, 3, 4, which is equivalent to ring count 1, 2, 3, 4, 5. So in our Enigma, we are only allowed to select the uh, rotor, the three rotor. So now we will select only the from rotor 0, 1, and 2. So let's try this. So yes, and then let's try. Let's try to encrypt the one letter only. So I input the letter J, and then we have the output of 5. So how this happen? So I'll show you. So in our input, I inputted the letter J. Let's find it out in this. So this is how our router works. So first, I inputted letter J, and then it has the equivalent of uh, the question mark. And then, so since we choose the rotor 0, 1, and 2, so we are only allowed to, the rotor will only rotate to rotor 0 to 2. So I inputted J, so it has the values of question mark, and then now it will goes to rotor 1 until it rotate completely. So next is from rotor 1. Since it has the question mark value, let's find first the question mark. So this is this one. And then since in our rotor 1, we have this L value, and then it will now proceed to rotor 2. Let's find the L. So we are now in the rotor 2. We have the question mark value again. So if we don't have the reflector, it will stop to, we will have the value of question mark. So in our program, we use the reflector, so it will go back to rotor 1. So when we say reflector, so when we start in the rotor 0, it will go back to rotor 0 when until it complete the cycle. So we end up in the rotor 2, which is the uh, question mark. So To complete the rotation, let's find the question mark in this rotor. This is the question mark that we have. So it has the value of x, and then now it will go back to rotor 1 until rotor 0. So let's find the x to rotor 1. So the x has the value of the equal, and then the equal will have the value of 5. So this is the value of when we input the letter J, it has the corresponding value of 5 through the use of reflector. So in our Enigma, since we inputted the letter J, it has the value of 5. And as you've noticed in our process, it has the exact value, which is 5. So let's try another. Let's continue. So let's type the other number. So if you notice, if I click any character in our Enigma, our rank setting is rotating. So as you click any character, it will rotate. So it will also count how many characters you've inputted in our Enigma. So let's say since our Enigma has the 90 character, so until it completed the cycle, it will count. This is how our Enigma machine function. So in our Enigma, we also have the feature of saving the output. So let's go now for our saving out the output. So when I save the output, it will pop up the message box of are you sure you want to save the message? If you click no, it will just remain to the last action that you did in our UI. And then when you save the output, yes, yeah, there will uh, there were also a message box that will pop up. So the message has been saved. So the output, you will see the output in our library. So let's see if the output is correct. So let's compare the output. So wait, sorry. So we have the output. Yeah. We started, let's say this one. We started in 5K, 1K, this one, and then we end up to CM. So the output is correct, this one. So this is how our Enigma functions. That's all. Thank you.